Welcome to the class of engineering mechanics. Today I will discuss about center of gravity. So first of all we have to know what is centroid. Actually the plane figures like triangle, circle have only areas and it has no masses, right? So the center of area of such figures is known as centroid. And the method of finding out the centroid of a figure is the same as that of finding out the center of gravity of a body. In many lectures or in many books, the authors also or the narrator also writes or tells center of gravity for centroid and vice versa, right? So first of all we have to know what are the methods of center of gravity, right? What are the methods? They are normally broadly classified as three types. Number one is by geometrical consideration. Okay, by geometrical consideration. And number two is by moments method. And number three is by graphical method. Okay, so these are the three methods that is used to determine or to find out the center of gravity of any body. So first of all let's try for the geometrical consideration. Okay, this is 1, this is 2 and this is 3. Okay, so first of all take geometrical consideration. Take a figure, random figure. I am taking a rectangular figure. This is a rectangle whose length is, I am taking is L and is breadth is, let's take H. Okay, so the center of gravity, first of all just remember the center of gravity of a uniform rod is at its middle point. Okay, so this one is L by 2 and this one is H by 2. Okay, so the center of gravity of a rectangle lies in this point. From here the distance is L by 2 and from here the distance is H by 2. Now so we can say the center of gravity of a triangle is that point where the diagonals meet at each other. Its diagonal is meeting in centroid position. It is also a middle point of the length as well as the breadth of the rectangle, as I showed earlier. Now take triangle. This is a triangle. Okay, like A, B, C, and this one was A, B, C, D. Okay, so in this triangle the center of gravity of a triangle is at that point where the three medians, right? Three medians. What is median? A median is a line connecting the vertex and the middle point of the opposite side. Okay, so the three medians of the triangle meet. Where the meet, the centroid is lies that point. So this is the middle point. This one. This is the middle point. This one, and this is the middle point. So this one. So you can see three median meets at this point. So this point is the center of gravity. This is G, right? Center of gravity, we signifies center of gravity as G. Here is also, this is called G. Now take another figure, that is trapezium. I am taking a trapezium. This is a trapezium. This is the two parallel side, unequal length parallel sides, and take A, B, C, D, right? And the height portion, this is the height of the trapezium, and take the height is H, and the base side taking B, and the shorter side, that is the upper side, take as A. Okay, so in this case, the center of gravity of a trapezium with parallel side A and B at a distance of H is separated by at a distance of H. The center of gravity will be from in this point, and the distance of this point will be, remember this thing, H by 3 into B plus 2A divided by B plus A. This is your B and this is your A, and this is the height is the H. Okay, and okay, I just forgot to mention, in case of triangle, the height will be how much? H by 3. If the height of the triangle is H, if this one is H, then from the base, the height of the centroid from the base will be H by 3. Okay, so next take a semicircle. I am taking a semicircle. What is like a semicircle? Semicircle is like, this is the half circle. Okay, right? This is a semicircle. I am taking the radius of the semicircle is R. So this distance is R, and the centroid will be formed in this point, and in this point the height will be 4R divided by 3 pi. Okay, this is A, B, C. This is the center of the semicircle. So this is O, and this is G, and this is G also. Okay, so the center of gravity of a semicircle at a distance of 4R by 3 pi from its base, measured along the vertical radius. This is the vertical radius, as I am showing in this figure. Okay, now so for geometrical consideration, that's all for today. Now from the next class I will teach you the center of gravity by moments and the center of gravity for the symmetrical section as well as for the unsymmetrical section. Okay, thank you.